I hope all of you are doing good. Let's start today's chapter, mensuration. After reading this chapter, you will be able to know about all these topics. Okay, so let's get started. Introduction. For any closed plane figure, we calculate perimeter, which is the length of its boundary, and the space enclosed within this boundary is called its area. For example, if we see, this is the perimeter, means the total length of the boundary, okay, or the length of the boundary you can see, and the space which is enclosed within the boundary, this is called area. Okay, we have also learned to find area of pathways and crossroads. Now we will try to find area and perimeter of some quadrilaters. In the later part, we will also learn to calculate volume and surface area of solids such as cube, cuboid and cylinder. Okay, here are some standard units of area and their relation. 1 centimeter square is equals to 100 millimeter square. 1 dm square is equals to 100 centimeter square. 1 meter square is equals to 10,000 centimeter square. Okay, here we are talking about meter square, squares, meter square, centimeter square or millimeter square. Okay, and 1 acre is equals to 100 meter square. 1 hectare is equals to 100 acre or 10,000 meter square. Let us recall some formula for area of rectilinear figure. Okay, you know the area of rectangle is length into breadth, area of triangle is half into base into height, area of parallelogram is base into height, area of circle is pi r square, and area of a square is side into side or side square. Okay, perimeter and area of a rectangle and square. Let L and B be length and breadth respectively of a rectangle, then area of a rectangle is length into breadth square units. Okay, if you have to find length, then area upon breadth units, and if you have to find breadth, then area upon length. Okay, let A be the side of a square, then perimeter of a square is 4 into A units. Side of a square is perimeter of a square upon 4, and area of a square is A into A, that is A square, and side of a square is under root area of a square units. Okay, let's do example 1. Length of a rectangle is given, which is 10 meter, and breadth is also 10 meter. We have to find its area in meter square. Okay, so area of a rectangle is length into breadth 10. Okay, but here is a difference. What? 10, this is 10 meter, length is 10 meter and breadth is 100 centimeter. Okay, so first we will make both units the same. Okay, so we have to find area in meter square, so we will convert centimeter in meter. Okay, so 10 upon 100. Okay, 0, 0 goes 0, 0. So the answer is 1 meter square. Okay, let's do exercise 11.1. A square of side 40 meter has the same perimeter as that of rectangle of length 45 meter. Which one will have a larger area? Okay, see what is given. Perimeter of a square is equals to perimeter of rectangle. Okay, perimeter of a square is 4 into side, perimeter of rectangle is 2, length plus breadth. Okay, 4, side is 40 meter, 2, length is given 45, breadth is not given. So we have to find out which one have larger area, but first we should know what is the breadth. Okay, 4 into 40 upon 2, 45 plus b. Okay, 2. So this 4 2s are 80. 80 is equals to 45 plus b, or b is equals to 80 minus 45. b is equals to 35 meter. This is the breadth. Now find the area. Area of a square is side square, that is 40 into 40, 1600 meter square, and area of a rectangle is what? Length into breadth, that is length is 45 and breadth is 35. Okay, let's do the multiplication. 5 5s are 25, 2 carry 4 5s are 20, plus 2 22. Okay, 3 5s are 15, 1 carry, 3 4s are 12, plus 1 13. 5 7 5 1. 1575 meter square. Okay, so clearly you can see this is the area of a square, this is the area of rectangle. Which has more area? Square has more area. okay, or you can say square has a larger area, right? Now, area of a trapezium. Trapezium is a quadrilateral which has only one pair of opposite sides parallel. In the given trapezium PQRS, PQ, this is parallel to RS. If we draw the diagonal PR, this one, the trapezium is divided into two triangles, namely PQR and PRS. So, area of trapezium PQRS is equals to area of triangle PQR plus area of triangle PRS, because we have divided this trapezium into two triangles, right? Let H be, this is the perpendicular, H be the perpendicular distance between parallel sides PQ and RS. It is also called the height of the trapezium, right? So, area of triangle PQR is what? Half into base into height, okay. In triangle PQR, as you can see, PQR, what is the base? Base is PQ. So, half PQ into H. And then area of triangle PRS is equals to half into, here SR is the base into H. Okay. So, area of trapezium, we will add this one and this one. So, half into PQ into H plus half into SR into H. Half plus half is what? So, we will take half and H as common, half H, then in bracket PQ plus SR. So, area of trapezium is what? Half in bracket sum of parallel sides into height, okay, or you can say perpendicular distance between them. Okay, let's do example 3. The parallel sides of a trapezium are 18 meter and 12 meter respectively, and the distance between them is 10 meter. What is the area of the trapezium? Okay, so we will apply this formula, okay, which is half into sum of parallel sides into height. So, area is half into sum of parallel sides into height. So, parallel sides are given 18 meter and 12 meter. Okay, so 18 plus 12, and what is the height? Height is 10. So, half into 18 plus 12 is 30 into 10. Okay, 12 5s are 2 5s are 10. Then 150 meter square. This is the area, right? Area of a general quadrilateral. Let us consider a quadrilateral ABCD. Its diagonal BD divides it into two triangles ABD and BCD. Let AL and CM be perpendiculars drawn from vertices A and C on diagonal BD respectively. Now, area of quadrilateral ABCD is equals to area of a triangle ABD plus area of BCD. Okay. So, half of quadrilateral is half. This is the triangle, okay. So, triangle formula, area of triangle is half into base into height. So, in triangle ABD, half BD is the base and AL is the height plus half into, then in BCD again here BD is the base and CM is the height. So, half BD is common, we will take BD outside the bracket, and then AL plus CM, okay. So, area of quadrilateral is half into one of its diagonals into sum of offsets corresponding to the diagonal. Okay. Let us do example 5. Find the area of the quadrilateral in which length of one diagonal is 36 centimeter and perpendicular drawn to it from the opposite vertices are 9 centimeter and 7 centimeter respectively. Okay. So, area of quadrilateral is what? Half into diagonal into in bracket sum of offsets. So, half into diagonal is what? 36 centimeter and sum of offsets 9 plus 7, okay. 18 into 9 plus 7 is what? 16, okay. So, 288 centimeter square is the answer, okay. Now, area of a special quadrilaterals. Let us try to find the area of rhombus. We know that rhombus is a special parallelogram in which all sides are equal and diagonals bisect each other at right angle. So if PQRS is a rhombus, then PR is perpendicular to QS. Now area of rhombus PQRS is area of triangle PQS plus area of triangle QRS. And you know the formula of area of triangle is half into base into height. So half into QS into PO plus half into QS into RO. Half into QS in bracket PO plus RO, then half into QS into PR. That is half into diagonal 1 into diagonal 2. Okay, this is the formula of area of a rhombus. Okay, so area of rhombus half into product of diagonals, right? Example 6, you have to find the area of rhombus and diagonals. Two diagonals are given here. So the area of rhombus formula is half into D1 into D2, that is product of diagonals. Okay, so half into diagonal 1 is 18 and diagonal 2 is 24, right? So 9 4s are 36, 21, 216 centimeters square, right? Next, area of polygon. We have seen that we can find area of any quadrilateral by dividing it into two triangles. Similar methods can be used to find the area of a polygon. For example, consider the following polygon A, B, C, D, E, R, P, Q, R, S, T. In figure 1, by constructing one diagonal, AC pentagon ABCDE is divided into two parts, namely triangle ABC and a trapezium ACTE. So area of pentagon ABCD is what? Area of triangle ABC plus area of trapezium ACDE, because we have divided this pentagon into two figures. One is triangle and other is trapezium. Okay. Similarly, in figure 2 also, by drawing two diagonals, namely PS and PR, pentagon is divided into three triangles, namely triangle PQR, triangle PRS and triangle PST. So the area of pentagon is what? We will add the area of these three triangles, because we have divided this pentagon into three triangles, right? Let's do example 7. Find the area of the regular hexagon ABCDEF of side 6 cm in the following figure. Okay, so this is the figure. Now let's see how we will divide this. Okay, now we have divided, see this has a 6 sides, so we have, this is a hexagon, right? Here CF divides it into two trapeziums which are identical, means which are congruent, means this is the hexagon, okay, and this line CF, this is dividing this hexagon into two congruent identical trapeziums. Okay, so what we have to do is, congruent means they are equal, right? So we will find only the area of one trapezium and then we'll multiply by 2. Okay, so the area of trapezium ABCF, that is this ABCF. Okay, so area of trapezium is what? Half into sum of parallel sides, which are 12 and 6, into height. Height is what? 5.2, as you can see here. Okay, so half into 12 plus 6 is 18 into, this is 5.29. Okay, 9 2s are 18, 9 5s are 45, 46, 46.8 centimeters square. Now area of hexagon, it has been divided into two trapeziums which are congruent, which are identical. So we will multiply this area by 2. 2 into 46.8, that is 93.6 centimeters square. So this is the answer. Okay. Now let's do exercise 11.2. The area of trapezium is 12 meters square. Height of the trapezium is 3 meter and one of the parallel sides is 1 meter more than the other. Okay. Find the length of the parallel sides of the trapezium. Okay. In this question, area is given. Area of trapezium is given 12 meters square. Height is also given, which is 3 meter, and one of the parallel side is 1 meter more than the other. Okay. Let the one side be. Let one of the parallel sides be. Parallel sides be x meter. So what is the other side? Other side is 1 more than the first side, that is x plus 1 meter. Now let's find out the area of trapezium. Okay, area of trapezium is what? Half into sum of parallel sides, that is x plus 1 into height, which is 3, and area is also given here. So half into 2x plus 1, 1 into 3. Okay, now we will transpose this here, 12 into 2 and 3 here. Okay, 2x plus 1. Now we will do here 3 4s. 8 is equals to 2x plus 1. 8 minus 1 is equals to 2x. 7 is equals to 2x, and x is equals to 7 by 2, or x is equals to 3.5 centimeter. This is the first side. Okay, now we have to find the other side. Other side is what? X plus 1, that is 3.5 plus 1, 4.5 centimeter. Okay, so we had to find the length of the parallel sides. One is 3.5, other is 4.5 centimeter, right? Next, solid shapes. Given below are some solid shapes which have 2 or more than 2 identical faces. For example, in a cuboid there are 3 pairs of identical faces. A cylindrical cylinder has 2 identical circular faces, its top and bottom. Okay. Surface area of cube, cuboid and cylinder. A. If we open a cuboid box and lay it flat, we can see its net as given below. If we have to find total surface area of this cuboid, we can find the surface area of its 6 faces as given in the net. Okay, see, this is the net of cuboid. So total surface area of cuboid is area 1 plus area 2 plus area 3 plus area 4 plus area 5 plus area 6. Okay, so here we get this. 2 into length into breadth plus breadth into height plus height into length, right? Where L, B and H are respectively the length, breadth and height of the cuboid. So lateral surface area is area 1 plus area 3 plus area 4 plus area 5. That is, this is the formula 2, then in bracket length plus breadth into height. Okay, let's do example 9. Total surface area we have to find. Here length, breadth and height are given. Okay, so the formula is this: 2 into length into breadth plus breadth into height plus height into length. Okay, so 2. Length is what? 20. Breadth is what? 12. 12. And then height is what? 18. Plus height is 18. Length is 20. Okay, so 2 into 240 plus 216 plus 360. Okay, so 2 into 816 is equals to 1632 centimeter square. Okay, next B, cube. For a cube, all its faces are identical, means the same, square, that is the length, breadth and height are all equal. So total surface area of a cube is 6 into area of its one face, that is 6 into a square, where A is the edge of the cube, and lateral surface area of cube is 4 into area of one face, that is 4a square. Okay, so this is the formula of lateral surface area and this is the formula of total surface area of a cube. Okay, next, cylinder. Most of the cylinders we see are right circular cylinders such as tin, round pillars, water pipes, etc. If you cut a hollow cylinder along its height, okay, if you cut along its height, we get a rectangular sheet which has breadth is equals to height of the cylinder, and the circumference of its base and top will become length of the rectangle, that is 2 pi r. Therefore, surface area of cylinder is surface area of rectangle. Then surface area of hollow cylinder is length into breadth, and curved surface area of cylinder is h into 2 pi r. So the surface area of hollow cylinder is this, 2 pi r h. Okay. If instead of hollow cylinder we have a solid cylinder, then total surface area of cylinder is curved surface area of cylinder plus area of base plus area of top. Now top and base of a cylinder are circular. See, top part and base, these two are circular, right? So total surface area of cylinder is what? Total surface area is 2 pi r h plus pi r square plus pi r square, right? So now 2 pi r square h plus 2 pi r square. Okay. Now 2 pi r common and in bracket h plus r. So this is the formula of total surface area of a cylinder. Okay. Example 10, a cuboid has a dimension as shown in this figure. We have to find its total surface area. Okay. So we will apply this formula as we did in the previous example. We have to find total surface area of cuboid. Okay. So this is the formula, 2 into length into breadth plus breadth into height plus height into length. Okay. So and then you will put all the values which are given. This is the length, this is the breadth, and this is the height. And then second part, area of 4 walls or lateral surface area of the cuboid. Okay. But before that, no more. Volume of cone is 1 by 3 volume of cylinder, that is 1 by 3 pi r square h. And slant height L is under root h square plus r square. Okay. Curved surface area is equals to pi r L and whole surface area is pi r, then in bracket L plus r. Okay. So here we are talking about the cone only. Okay. Now the second part of the question says we have to find out the lateral surface area of cuboid. Okay. Which is 2 into length plus breadth into height. Okay. So 2 into length is what? 12 plus 10, height is 18. So 2 into 22 into 8 is a 352 centimeters square. This is the answer. Okay. No more. Lateral surface area of cuboid, it is a surface area of walls excluding the top and bottom, and therefore lateral surface area is 2 h into L plus h into B, that is 2h into in bracket L plus B. Okay. Let's do exercise 11.3. The base area of a cube is 18 square centimeter. What is the total surface area of the cube? Okay, you know the total surface area of the cube is 6a square. So first you will find out the side and the base area is given to you. Okay, and in question number 2, you have to find out the area of 4 walls of the room. Length, breadth and height is given there. Okay, so you will put the formula of area of 4 walls and then you will find the area, right? Next, volume of solids, that is cubes, cuboids and cylinder. The space occupied by a solid body is called its volume. Volume of a rectangular solid is product of its dimensions. Therefore, volume of a cuboid of length, breadth and height as L, B and H respectively will be, volume of cuboid is length into breadth into height. Okay. Similarly, volume of a cube of edge A will be volume of cube is A into A, that is A cube or edge cube, and volume of a right circular cylinder is area of base into height, that is pi r square h. Okay, so this is the formula of volume of cylinder. Okay. Capacity is the quantity that a container can hold. You know that if a container holds 1000 centimeter cube of water, then the capacity of the container is 1000 centimeter cube. Capacity is also measured in terms of liters for liquids. Here are some standard units of volume and their relation. See, 1 centimeter cube is equals to 1000 millimeter cube. 1 meter cube is equals to 10 lakh centimeter cube. 1000 centimeter cube is equals to 1 liter. Okay, 1 meter cube is equals to 1000 liter, or you can write this, and 1 liter is equals to 1000 ml, or 1000 centimeter cube, or 1 ml is equals to 1 centimeter cube. Okay. Example 13, a cuboid has dimensions 12 centimeter, means this is length, this is breadth and this is height. We have to find the volume. So volume of cuboid is what? Formula is length into breadth into height. Length is 12, breadth is 10 and height is 8. So 120 into 8. 960 centimeter cube. Okay, here we are talking about volume. Volume always, unit of volume is always cube. Okay. Let's do exercise 11.4. A godown is in the form of a cuboid of measures this and how many cuboidal boxes can be stored in it if the dimension of each box is 40 centimeter, 30 centimeter and 20 centimeter. Okay, first see, these dimensions are in meter and these dimensions are in centimeter. Okay, so first dimensions of cuboids are length is equals to 80 meter or 80 into 100, that is 8000 centimeter. Breadth is 60 meter or 60 into 100, 6000 centimeter. And height is 40 meter, that is 440 into 100 is equals to 4000 centimeter. Okay, we have to find out the how many cuboidal boxes. Okay, so number of boxes is equals to what? Volume of godown, which is in cuboidal shape, upon volume of box. Okay, now see, volume of godown is what? 8000 into 6000 into 4000 upon volume of box, and the dimensions 40 into 30 into 20. Now 1 2 3 1 2 3 0 4, then 2 3 0 0 0, then 3. So the number of boxes 8000 000. That means 80 lakhs boxes can be stored in that godown, right students? Now students, I hope you have understood this chapter. Now you will do practice of this chapter.